Hello, ladies and gentlemen. Today we are going to start chapter 11. And these first few lessons should be fairly straightforward and familiar, but I would really encourage you to pull up the blank lesson, follow along, or for sure take notes. Even though these formulas are pretty basic and familiar to you, we are going to get into some shapes, areas of shapes that you're not as familiar with, and it's not that anything is really that difficult, but they can you can get mixed up. And also all of these flat two-dimensional areas that we are going to cover in chapter 11 are going to repeat. We're going to need to know all of them when we move into chapter 12, which is volume and surface area of three-dimensional figures. So to get started, we are talking in these first two lessons, section 11.1 and 11.2, about the area of rectangles and other quadrilaterals. So rectangle, you're pretty familiar with. Really, when we talk about area, we're talking about how many square units of a certain size fit into a certain region or area. So if you look at this example that we have here, we would have as you're familiar with area of a rectangle, you might have learned it as length times width. We're going to use base times the height because that is going to carry over to all of our other quadrilaterals that we're going to work on. We're going to have a base rather than a length and a width. That really only refers to rectangles and squares. So in this particular example, if we were to keep drawing in all of these square units, what we would figure out is that there are 5 rows and 7 columns, and we would have a total of 7 times 5, which is 35 square units. That's what that area would be. Okay, so area of a rectangle, pretty basic, but again, remember that we're going to have a lot of different formulas, so make sure you have that in your head. Area of a rectangle equals the base times the height. Now, I would encourage you also to pause the video as we go through this and make sure you get these formulas down, again, because they are going to come back. So when we look at a parallelogram, you might already know that the area is still the base times the height. But why? Well, it turns out if you take this little piece of the parallelogram and you move it over here, what you end up with, I guess I'll use a dash line, what you end up with is you actually end up with, if we move that over here and then we kind of get rid of this, what we have now is a rectangle. Okay, so really the formulas are the same. We have the area of a rectangle or of a parallelogram is the base times the height. Not anything new for you, I'm sure, and neither is the area of a triangle, and most of you know, and you should know and commit this to memory, that the area of any triangle is 1/2 the base times the height. But again, why? Well, if we take this entire triangle right here and we duplicate it, we can actually slide it and duplicate it, and we end up with, really, we have still a parallelogram. But the actual triangle that we are trying to find the area of is only half of the parallelogram. So when we take the base times the height, we're going to have to take half of that when we multiply them together in order to get just that triangle. And that's true of any triangle. It doesn't matter if it's a right triangle or an isosceles or equilateral. You'd still be able to duplicate it and either form a rectangle or a parallelogram, and that's why the formula here is area equals 1/2 base times the height. So let's move on to trapezoid. You've probably maybe encountered some formulas for trapezoid, but you might not be as familiar with memorizing the actual formula. Okay, so let's take a look. We've been kind of duplicating these figures and so forth. Well, it turns out if I, again, go ahead and take this trapezoid right here, and I duplicate it, in other words, and if we were doing this in class, I actually have these smart lessons set up with this already duplicated, and I can turn and flip it and so on. But what ends up happening is I end up, when I duplicate it, of course mine's not going to be as perfect as it would be, but when we duplicate that, what we end up with, again, is we end up with a larger, come on, give me my color. Okay, we're going to be finicky today. We end up with a larger parallelogram right here. And we know the formula for a parallelogram is the base times the height. But it turns out that this entire base right here, if I can get a color. Wow, my pen is not very cooperative today. But if we take a look at this, just go with what we have. If we take a look at this base right here, that is really this base 1, and this base 2 is what's right here. So that means that in order to get the entire base, we have to take base 1 plus base 2, that's the entire base, and multiply it by the height. But again, since we are only really dealing with half of it for the trapezoid, we have to take 1/2 of that calculation. So area of a trapezoid is 1/2 base 1 plus base 2 times the height. Now when I think about this, this is just a model, this is one way of thinking about it, but another way I tend to think about it is I look at this parallelogram right here, and I'm like, hey, or sorry, this trapezoid, and I'm like, hey, it kind of fits in with our parallelograms. I mean, it's got one pair of parallel sides, and it'd be nice if we could take the base times the height, but our bases are different values. So I think of this right here as taking the average of the bases. So that's kind of another way of looking at it. So that 1/2 times the base 1 plus the base 2 is taking the average of the bases. All right, so let's look at one maybe you haven't encountered yet before, and this would be the area of any kite or rhombus. So when we look at a kite and a rhombus, we really don't have a base and a height, okay? But what we do have is something called a diagonal. So these are the diagonals. So this is diagonal 2 right here. Let's see if I can actually get another highlighted color. I guess not. This right here then is diagonal 1. So that's what those are referring to. So if we look at this kite, and again, if we go with the same kind of strategy to kind of make sense of all of this, if we duplicate and we take this piece right here of the kite and we duplicate it and we move it down here, what we would have is we could slide it down here. And if we do the same thing with this piece of the kite and duplicate it, we could actually slide it down here. And so now what we would have is, again, going back, what we have right here is really now, with this piece, we haven't really added any pieces, but what we have is really kind of a rectangle. And we know the area of a rectangle is base times the height, but in this case, our base is diagonal 2. And our height is actually only this part of the diagonal. So we have 1/2 of diagonal 1 times diagonal 2. Now there are other ways to look at this for sure, okay? And there are lots of ways to explore and come up with this on your own, but kind of sticking with the same pieces and base and height and going back to rectangles and parallelograms, that's what we have for these formulas. So we have covered all of the formulas for these first 2 lessons in one shot because they're really pretty simple. And if you just write them down, you'll be able to use them. So again, go back, pause the video, make sure you have these down as we work through these examples. Again, follow along with the blank lesson. So this is pretty basic. To find the area, we know it's the base times the height. So we're going to take 12 times 5, which is 60. And we always include a square unit because, again, this is made up of how many units. In this case, it would be 1 meter by 1 meter units squared that make up this particular area. So 60 meters squared would be our answer. So let's move on to something a little bit more challenging. Doesn't look that bad, it's just a simple parallelogram, but we know that the area is the base times the height. Well, because it's a parallelogram, we know that this side right here is going to be congruent to this side right here. So I can go ahead and mark those congruent, but I know my base then is 16 feet. Okay, my problem here lies in my height. I don't know what my height is. And I don't really know anything else except that this height has to be perpendicular. So I'm going to actually have to go back and use trig, SOHCAHTOA. I'm going to have to use trig to find this height. Well, how do I do that? Because I don't know this angle. But I do, because in a parallelogram, we know that this angle right here and this second angle right here are consecutive interior angles, so they're supplementary. So if I take 125 and I subtract that from 180, what I get is this angle right here is 55 degrees. So now I look at this H is the opposite, and this 7 right here is the hypotenuse. So now when I use opposite and hypotenuse, that's going to be my SO or sine. So I'm going to take the sine of 55 and set it equal to H over 7. And now it's just simply cross multiply. And again, you should be working these out on your calculator for sure. And don't forget your calculator needs to be in degree mode whenever using trig or SOHCAHTOA. But when you calculate that, it's not going to come out perfect. So we can use that little approximate symbol. So my height is approximately 5.73. So there's my height. So now I can put that in, 5.73. So now I get the area of this parallelogram is, again, just plug this into your calculator and you get 91.75 feet squared. If they don't tell you what to round to, then just always round to the nearest hundredth. Okay, moving on. Find this area. Okay, again, simple. It's just a triangle, and we know the formula. And I always like to write these down just to practice and make sure I'm not messing it up with another one. So the area is 1/2 the base times the height. So I know that my base is 17, but again, my height here, I don't know. But I can use the same strategy I just used, okay? Because now they gave me this angle is 35, and this H is the opposite side, and this side right here, because it's directly across from the right angle, is the hypotenuse. So again, you set up your ratio of the sine of 35 equals your height over 13. And when I solve, that gives me a height of approximately 7.46. So now I go ahead and put that in here for my height, and that gives me an area. Again, it's not going to be exact, but approximately 63.38 millimeters squared. And last but not least, let's find the area for practice, since this is probably a shape that you're less familiar with, and let's find the area of a kite. So again, I would practice writing these just over and over because it helps you commit them to memory, but we know the area of a kite is 1/2 diagonal 1 times diagonal 2. Now, actually going back from to chapter 8 that you just tested on, I mean, this didn't tell us it was a kite, so how do I know it's a kite? Well, first of all, I can see that both pairs of opposite sides are congruent. They happen to all four be the same, so it either has to be a square or a rhombus or kite, right? Kite/rhombus. And so what we have here is we have a rhombus, which ends up being the same formula as a kite. So I know that now because I don't know anything about the angles. I can't say it's a square. So that's where I need to use the diagonals. Here's one of the diagonals. Here's the other. It doesn't matter which you call diagonal 1 or diagonal 2. Okay, that's arbitrary. But now we can take area is equal to 1/2 of diagonal 1 times diagonal 2. Well, remember that in any parallelogram, the diagonals bisect each other. So that means this also has to be 3 centimeters. So that means one of the diagonals is 6. Now I need to work on that other diagonal. I don't know the other diagonal. So how can I find this other diagonal? Because I don't know either piece. And I don't know, for some reason, oh, I did get another color now. So if I could find this part right here, then I could just double it. Well, I know that in a kite and in a rhombus, okay, going back, remember our diagonals are perpendicular. So I can use the Pythagorean theorem to find this piece. I'm going to call it x. So I'm going to take 3 squared plus x squared, and that's going to equal 9 squared. So now when I subtract the 9 from the 81, I get x squared equals the square root of 72. And if I want to put that in simplest radical form, remember this is this is 36 times 2. Take the square root of each one. Sorry, that got written a little messy, so I'll try that again. 72 is 36 times 2, so I'm going to get 6 root 2. If you'd rather just go ahead and get a decimal for that, that's totally fine as well. So now I'm going to put 6 square root of 2 in, and now I can find my area then is approximately 50.91 centimeters squared. Now, if you use a decimal when you find the, oh my goodness. So I put 6 root 2 in there, but that was only part of it. I need to double that. So let's go back. My bad here. And let's go back and remember that this is also 6 root 2, and this is 6 root 2. So I need 6 root 2 times 2. Or I could just put 12 root 2 in there. So apologize for that. And when we calculate 1/2 times 6 root 2 times 2, that is going to give us then our 50.91 centimeters squared. So hopefully this makes sense. I would encourage you, if this is a little rusty or a little rough, maybe go back and read sections 11.1 and 11.2. This is kind of a combined lesson. And then tomorrow we're going to work on some applications of 11.1 and 11.2, which will give you some more practice. So when we look at these learning targets here, these are the things that you should be able to understand and know how to do after this video and also after doing the homework problems. And then you can see that I have kind of let you choose, okay, from each section. This is like 11.2, and this one over here is, or sorry, this is 11.2, and this one is 11.1. And so you're going to pick 10 from each section. So pick 10 from here and 10 from here. All right, take advantage of my office hours. Email me any point in time or message me, and good luck and have a great day.